This video should help you study for the quiz you'll be taking in class next time. There's 3 sections that we've gone over so far in Chapter 6, and I've briefly listed here the content from each of those sections. 6.1, transition diagrams and transition matrices, and in Section 6.2 we looked at matrix arithmetic, in particular 3 different types of operations you can perform with matrices. And then in section 6.3, we looked at how to represent as well as solve a system of linear equations using matrices. So I'm going to go through briefly each of these things in more detail. From section 6.1, you need to be able to do the 3 things listed here. If I give you a situation where people are transitioning from one choice to another, from one day to the next or one week to the next, you need to be able to represent the situation both with a transition diagram as well as a transition matrix. And then you need to use that information to determine how many people would choose each option on subsequent days. I'm not going to go through the details of this in this video because we've done that in class. We did a warm-up just like this. The one thing I will suggest is that you should be able to do this, especially with a transition matrix, even if there's more than 2 choices. So think about that. There were some classwork problems that involved more than 2 choices. The section on matrix arithmetic is going to require you to perform these calculations without a calculator. So just briefly, a reminder that when there's a scalar or number parked outside of a matrix, you just multiply everything in the matrix by that number. So I'm going to triple each of these. 2 times 3, negative 1 times 3, 0 times 3, 8 times 3, 4 times 3, and negative 5 times 3. And then the same thing here, I'm going to multiply everything by 6. Negative 6, negative 12, 18, 6, 0, and 24. And then you should be able to add or subtract. In this case, subtract, so 6 minus negative 6 is 12. Negative 3 minus negative 12 is 9. 0 minus 18 is negative 18. 24 minus 6 is 18, 12 minus 0 is 12, and negative 15 minus 24 is negative 39. You should also be able to explain when you can perform matrix arithmetic and when you cannot. In the case of addition and subtraction, the matrices have to have exactly the same dimensions or you can't perform the arithmetic. As far as scalar multiplication goes, you can multiply any matrix by any scalar. There's no real restrictions there. Similarly, you need to be able to explain when you can multiply 2 matrices together. This is an example where you can, because the first one has dimensions 2 by 2, and I don't know, I didn't represent it this way in class, but now that I'm thinking about it, that might make more sense. And you're multiplying it by one that is 2 by 3, and since the inner dimensions match, you can do the computation, and the resulting matrix should be 2 by 3. Those are the outer numbers. So, and then just a brief reminder of how that works. I'm going to get my space here for a 2 by 3. So I'm going to multiply this row by each column in the second matrix. So 2 times negative 1, negative 2, plus negative 3 times 2, negative 6. So negative 2 plus negative 6 is negative 8. Then I use the 2, negative 3 with the second row, and I get 16 plus 0 is 16. And then I'm going to use the 2, negative 3 one more time, this time with the final column here. So 2 times negative 2, negative 4 plus negative 12 is negative 16. Then I'm going to do the same thing with the second row and each column. So negative 4 plus 10 is 6. 32 plus 0 is 32. And for my last entry, -8 plus 20 is 12. Again, you're going to have to be able to do that without a calculator. Section 6.3 involved representing and solving matrices, representing and solving systems of equations using matrices. So this will require a calculator, and so what you're going to do to find the solution here, you're going to take the matrix made up of the coefficients for x, y, z, and w. Oops, that should be a 1. X, Y, Z, and W. And then in the next one it's X, Y, Z, W, X, Y, Z, W, and X, Y, Z, W. And remember that then gets inverted. You do that with your calculator. And multiplied by the column matrix, 15, -1, -16, and 7. You also need to be able to represent the system using matrices. I'm not going to go through that here. That was the previous video. If you crank out this matrix arithmetic in your calculator, the result is going to be -1, 2, -2, and 8. You should check that on your own, but then you need to know that what that means is x is -1, y is 2, z is -2, and w is 8. And that's what you need to be able to do for the quiz next time.